For 240-volt tennis court lights, either a 2-pole or a 1-pole contactor can be implemented. However, a 2-pole contactor is generally recommended for enhanced safety and reliability. A 2-pole contactor disconnects both hot legs of the circuit, ensuring that no electricity flows to the lights when they are off. This significantly reduces the risk of electrical shocks or potential fires. Furthermore, 2-pole contactors are considered more reliable than their 1-pole counterparts, minimizing the chance of a single point of failure. In a 1-pole contactor system, if one pole fails, the lights may remain partially energized, creating a hazardous situation. Conversely, a 1-pole contactor offers some advantages, primarily in terms of cost-effectiveness, as they are typically less expensive than 2-pole contactors. Installation can also be simpler, potentially saving time and effort during the wiring process. Several factors should be considered when making a choice. Firstly, local electrical codes may mandate the use of a 2-pole contactor for specific lighting applications. It is crucial to consult the local code for any specific requirements. Secondly, if electrical knowledge or experience is limited, it is advisable to opt for a 2-pole contactor for increased safety and reassurance. Thirdly, cost and availability play a role. If budget constraints are a primary concern and 2-pole contactors are not readily accessible, a 1-pole contactor with a neutral tie may be considered. However, extra precautions should be taken to ensure safety. In conclusion, while both 2-pole and 1-pole contactors can be utilized for 240-volt tennis court lights outdoors, the recommendation leans towards a 2-pole contactor due to its enhanced safety and reliability features. If cost is a significant factor, a 1-pole contactor with a neutral tie can be an alternative, provided that it adheres to local code stipulations and is installed by a qualified electrician. When dealing with electrical installations, safety should always be the top priority. It is crucial to understand the specific requirements of the installation, the capabilities of the equipment being used, and the relevant electrical codes. If there is any doubt about the safety or correctness of an installation, it is always best to consult with a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect oneself and others. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and ensuring that all circuits are de-energized before working on them. It is also important to follow all manufacturers' instructions and recommendations for the installation and operation of electrical equipment. Improperly installed or maintained electrical equipment can create a safety hazard, leading to electrical shock, fire, or other serious injuries. When selecting a contactor for a lighting application, it is important to consider the voltage and current requirements of the lights. The contactor must be rated for the voltage and current that it will be switching. It is also important to consider the type of load that the contactor will be switching. Lighting loads can be inductive, which means that they can generate voltage spikes when the circuit is opened. These voltage spikes can damage the contactor, so it is important to select a contactor that is rated for inductive loads. In addition to the voltage, current, and load type, it is also important to consider the environmental conditions in which the contactor will be used. If the contactor will be exposed to moisture, dust, or other contaminants, it is important to select a contactor that is rated for those conditions. Contactors are available in a variety of sizes and configurations. The size of the contactor is determined by the current that it is rated to switch. The configuration of the contactor is determined by the number of poles and the number of throws. A pole is a single set of contacts that can be opened or closed. A throw is the number of different positions that the contacts can be in. A single pole, single throw SPST contactor has one set of contacts that can be either open or closed. A single pole, double throw SPDT contactor has one set of contacts that can be in one of two positions. A double pole, single throw DPST contactor has two sets of contacts that can be either open or closed. A double pole, double throw DPDT contactor has two sets of contacts that can be in one of two positions. For lighting applications, a DPST contactor is typically used. This type of contactor has two sets of contacts, one for each hot leg of the circuit. When the contactor is closed, both hot legs of the circuit are connected to the lights. When the contactor is open, both hot legs of the circuit are disconnected from the lights. This ensures that the lights are completely de-energized when they are off. When installing a contactor, it is important to follow all manufacturers' instructions and recommendations. The contactor should be mounted in a suitable enclosure to protect it from the environment. The wiring should be properly sized and installed according to the National Electrical Code, or NEC. The contactor should be properly grounded to prevent electrical shock. Once the contactor is installed, it should be tested to ensure that it is working properly. The voltage and current should be measured to ensure that they are within the rated limits of the contactor. The contactor should be operated several times to ensure that it is opening and closing properly. If the contactor is not working properly, it should be replaced. Regular maintenance is important to ensure that the contactor continues to operate properly. The contact should be inspected periodically for wear and corrosion. The wiring should be inspected for damage. The contactor should be cleaned to remove any dust or dirt. If any problems are found, the contactor should be repaired or replaced. By following these tips, it is possible to select, install, and maintain a contactor that will provide reliable and safe operation for many years. In summary, the choice between a 1-pole and 2-pole contactor for 240-volt lighting depends on factors such as safety requirements, budget, and local electrical codes. A 2-pole contactor provides increased safety by disconnecting both hot legs of the circuit, while a 1-pole contactor may be more cost-effective. However, it is important to ensure that the installation meets all applicable codes and is performed by a qualified electrician. Always prioritize safety when working with electrical systems. Firstly, understand the application of contactors. Contactors are electrically controlled switches used to control a circuit. They are commonly used to switch power to lighting, heating, and motor circuits. Contactors are similar to relays, but they are typically used for higher current applications. Secondly, know the voltage requirements. The voltage of the lighting circuit is a critical factor in determining the type of contactor that should be used. In this case, the lighting circuit is 240 volts. Thirdly, explore the 1-pole contactor. A 1-pole contactor only switches one leg of the 240-volt circuit. The other leg is connected directly to the load. This type of contactor is less expensive than a 2-pole contactor, but it does not provide the same level of safety. Fourthly, delve into the 2-pole contactor. A 2-pole contactor switches both legs of the 240-volt circuit. This provides a higher level of safety because both legs of the circuit are disconnected when the contactor is open. Fifthly, consider safety implications. Using a 2-pole contactor is generally recommended for 240-volt lighting circuits because it provides a higher level of safety. If a 1-pole contactor is used, there is a risk that the load could still be energized even when the contactor is open. This could create a safety hazard if someone were to come into contact with the load. Sixthly, note the code compliance. Local electrical codes may require the use of a 2-pole contactor for certain lighting applications. It is important to check the local codes before installing a contactor to ensure that it meets all requirements. Seventhly, think about costs and installation. 1-pole contactors are generally less expensive and easier to install than 2-pole contactors. However, the increased safety provided by a 2-pole contactor is often worth the extra cost and effort. Eighthly, analyze the neutral tie option. When using a 1-pole contactor, one might consider tying the neutral. However, this does not provide the same level of safety as a 2-pole contactor and may not be permitted by local electrical codes. Ninthly, be aware of the potential hazards. Always energize the circuit before working on any electrical equipment. Follow all safety precautions and wear appropriate personal protective equipment. Tenthly, be qualified. If you are not comfortable working with electrical equipment, it is best to hire a qualified electrician to do the work. Choosing the right contactor and installing it correctly is essential for the safe and reliable operation of a 240-volt lighting circuit. Consider all factors and follow all applicable codes and regulations. For example, the NEC is a widely adopted code for electrical installations. This code provides guidelines for the safe installation of electrical systems, including lighting circuits and contactors. Article 404.2 2 of the NEC covers the requirements for switches and contactors used in lighting circuits. This section specifies the types of switches and contactors that are permitted for use in different applications. Article 404.2 2b specifically addresses the use of switches and contactors in 240-volt lighting circuits. This section requires that switches and contactors used in 240-volt lighting circuits be rated for the voltage and current of the circuit. The section also requires that the switches and contactors be capable of interrupting the circuit under fault conditions. Article 404.2(c) provides additional requirements for switches and contactors used in lighting circuits that supply emergency lighting. This section requires that the switches and contactors be designed to prevent accidental disconnection of the emergency lighting circuit. Article 408.36 covers the requirements for overcurrent protection of lighting circuits. This section requires that lighting circuits be protected by overcurrent devices, such as fuses or circuit breakers, that are rated to protect the circuit from overloads and short circuits. The overcurrent devices must be sized according to the ampacity of the conductors in the circuit. Article 210.21 covers the requirements for branch circuits that supply lighting. This section specifies the types of receptacles and lighting outlets that are permitted on branch circuits. Article 210.21b specifically addresses the use of multi-wire branch circuits for lighting. This section requires that multi-wire branch circuits that supply lighting be provided with a neutral conductor that is sized to carry the maximum unbalanced load in the circuit. When installing a 240-volt lighting circuit with a contactor, it is important to follow all applicable requirements of the NEC. This will help to ensure that the circuit is installed safely and correctly. Always consult the latest edition of the NEC and any applicable local codes before beginning any electrical work. It is also important to understand the specific requirements of the lighting fixtures and contactors that are being used. The manufacturer's instructions should be carefully followed to ensure that the equipment is installed correctly. In addition to the NEC, there may be other applicable standards and guidelines that should be followed. For example, the National Electrical Manufacturers Association, or NEMA, publishes standards for electrical equipment, including contactors. These standards provide guidance on the design, testing, and performance of electrical equipment. The Institute of Electrical and Electronics Engineers, or IEE, also publishes standards related to electrical engineering. These standards cover a wide range of topics, including power systems, electrical safety, and electromagnetic compatibility. When selecting a contactor for a 240-volt lighting circuit, it is important to consider the following factors. Firstly, the voltage rating. The contactor must be rated for the voltage of the circuit. Secondly, the current rating. The contactor must be rated for the current that will flow through the circuit. Thirdly, the number of poles. The contactor must have the appropriate number of poles for the circuit. Fourthly, the type of enclosure. The contactor must be installed in an enclosure that is appropriate for the environment in which it will be used. Fifthly, the listing. The contactor should be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. When installing a contactor, it is important to follow all manufacturers' instructions and recommendations. The contactor should be mounted securely in the enclosure. The wiring should be properly sized and connected to the contactor terminals. The enclosure should be properly grounded. Once the contactor is installed, it should be tested to ensure that it is working properly. The voltage and current should be measured to ensure that they are within the rated limits of the contactor. The contactor should be operated several times to ensure that it is opening and closing properly. If the contactor is not working properly, it should be replaced. Regular maintenance is important to ensure that the contactor continues to operate properly. The contact should be inspected periodically for wear and corrosion. The wiring should be inspected for damage. The contactor should be cleaned to remove any dust or dirt. If any problems are found, the contactor should be repaired or replaced. By following these tips, it is possible to select, install, and maintain a contactor that will provide reliable and safe operation for many years. The choice between a 1-pole and 2-pole contactor often hinges on a few key areas, beginning with safety. As highlighted, a 2-pole contactor disconnects both live wires, thus fully isolating the circuit. This full isolation significantly curtails the risk of electric shock during maintenance or any unforeseen circumstances. Even when the lights are off, a 1-pole contactor leaves one live wire connected, presenting a potential hazard. Secondly is code compliance. Many local and national electrical codes mandate the use of 2-pole contactors for specific applications, notably in commercial or public settings where safety standards are stringent. Checking your local code is non-negotiable to ensure your installation aligns with legal requirements. Thirdly, there is cost. 1-pole contactors generally come with a lower price tag than their 2-pole counterparts. If the budget is a tight constraint and the application isn't governed by stringent safety regulations, a 1-pole contactor might seem like a viable option. However, remember to balance initial savings against potential long-term safety risks. Fourthly is installation. Wiring a 1-pole contactor is typically simpler, which can save time and labor costs. However, simpler doesn't always translate to safer. The ease of installation should never overshadow adherence to safety standards and code requirements. Fifthly, think about reliability. While both types are generally reliable, the 2-pole design offers a marginal advantage in terms of fault tolerance. If 1-pole fails, the entire circuit is still safely disconnected, unlike a 1-pole setup where a failure could leave the circuit partially energized. Sixthly, consider the application. This specific application also plays a crucial role. For instance, in a residential setting with less stringent codes and low risk exposure, a 1-pole contactor might suffice. However, for public spaces like tennis courts, where multiple users interact with the equipment, the added safety of a 2-pole contactor is highly recommended. Seventhly, you have future-proofing. Investing in a 2-pole contactor can be seen as future-proofing your installation. As safety standards evolve and become more stringent, having a 2-pole system ensures compliance with potential future regulations, saving you from costly upgrades down the line. Eighthly, note the long-term costs. While the initial cost might be higher for a 2-pole contactor, consider the long-term costs associated with potential safety hazards, legal liabilities, or code violations that could arise from using a less safe 1-pole option. Ninthly, research and compare. Take the time to research different brands and models of both 1-pole and 2-pole contactors. Compare their specifications, ratings, and features to make an informed decision that aligns with your specific needs and budget. 10thly, consult an expert. When in doubt, always consult a qualified electrician. They can assess your specific situation, advise on the best type of contactor for your application, and ensure a safe and code-compliant installation. Electrical work should never be a DIY project unless you possess the necessary expertise and certifications. In the context of outdoor tennis court lighting, the safety factor takes precedence. Given the public nature of the space and the potential for exposure to various weather conditions, the enhanced safety offered by a 2-pole contactor makes it the more prudent choice. While cost savings might be tempting, compromising on safety is a risk not worth taking. Always prioritize a safe and code-compliant installation, even if it means a slightly higher initial investment. Remember to always consult the NEC, specifically Article 404, for switch and contactor requirements. Also, Article 210 and 215 will provide branch circuit and feeder information. Understanding conductor ampacity is also key. Table 310.15.16 provides ampacity information for conductors based on insulation type and temperature rating.